A, B, and C were just basic multiplication, basic permutations, basic combinations. These are going to have some of the tricks. So for example, the number of ways to arrange the letters in the word mathematics. So order matters. So let's talk about how to rearrange. There are 4, 8, 11 different letters in the word mathematics. If we assumed every letter was unique, it would be 11 factorial. However, not every letter is unique. This calculation treats every letter as special. Because that is not true, we need to balance that out in our calculation. So the best way to balance out multiplication is with division. For example, there are 2 m's. So we need to divide by 2 factorial because the m's are not unique. There are 2 a's, so we need to divide by 2 factorial. There are 2 t's, so we need to divide by 2 factorial. And I think that's all for the repeating letters. There are multiple m's, there are multiple t's, there are multiple a's, and that should be it. So we're going to actually bring this calculation this way. $11 factorial is a pretty large number, 399168800. And then 2 factorial, 2 factorial, 2 factorial. That's really going to be 2 times 2 times 2. So that's 8. So we divide that total by 8. Our final answer for this value is going to be something like 4,989,600. The key here is if we're rearranging words, the order matters. So we use factorial. But if not every letter is unique, we need to look at each one of those letters, see how many there are, and divide by that amount factorial. If for some reason there was 5 x's, we would divide by 5 factorial. Or if there were 3 p's, we would divide by 3p. It's a pretty easy little adjustment once we know what to do. In E, there are 5 freshmen, 5 sophomores, 5 juniors, and 5 seniors nominated for awards. For each grade level, how many possible ways are there? Oops, I misspelled there. How many possible ways are there to choose 2 recipients for the award? So this represents where we have to multiply different combinatorial numbers together. Let's just give the freshmen their award first. There are 5 freshmen. We have to choose 2. So that's 5 choose 2. 5 choose 2 is 10. There are 5 sophomores, and we still have to choose 2 for the award. So there's 5 sophomores, and we choose 2. So there's 10 different ways to choose the sophomores. 5 juniors, 2 awards, 5 choose 2. And 5 seniors, 2 awards. It's 5 choose 2. Oop. So for each grade level, there's 10 different ways, right? There's 10 different ways for the sophomore level. There's 10 different ways for the junior level, the senior level, the freshman level, etc. This follow-up question is, what is the total number of possible ways to hand out all 8 awards? Well, we have 10 choices for the freshmen, times 10 choices for the sophomores, 10 choices for the juniors, 10 choices for the seniors. We wind up with 1,000 different ways. Right? I wanted to take this problem and split it into chunks. We've had a few like this, where you have a total number of people, which is 20. But really, you narrow it down to smaller categories, and you do choose problems for each smaller category and then multiply the results together. This is a good example of that. All right, let's look at F. Jose, Candace, John, Christy, Alex all arrive for the bus in a random order. How many possible ways can the student show up with John first and Christy second? Well, look, there's 1, 2, 3, 4, 5 people. So let's write out 5 slots. We do not have choices for that first slot. It's going to be John. We do not have choices for that second slot. It's going to be Christy. But we do have choices for person number 3. We got rid of John and Christy, so we still have 3 to choose from. Once we do that, we have 2 choices for the last person, second to last person, and that leaves us 1 choice for the last person. So it's really just going to be 3, 2, 1. It's going to be 3 factorial, or 6 different ways. What is the probability that they show up in this order? So this is where we start introducing probability combined with combinatorial values. So if you recall, we have our favorable outcomes, and then we have our total outcomes. In this scenario, there are 6 ways for them to line up that are favorable. And what we mean by favorable, it means they meet the criteria of the scenario. There are 6 ways that meet the criteria of the scenario. The total number just means how many different ways can 5 people line up for the bus. So the total number is going to be 5 factorial. And what we wind up with is 6 divided by 120. We could simplify that as 1 over 20. Or if you divided this out, you get a probability of 0.05. Okay. So probability requires setting up a fraction. You have your favorable outcome, so you need to read the question and basically say, okay, to do a specific task, like John Christie first, how many ways are there? And then you get rid of that restriction and just say, okay, if you have 5 people, how many ways can they stand in line? 120. Okay, please check the next video for the next couple of questions in this section. This was D, E, and F. These cover some of the kind of tricky versions, a trickier permutations problem, a trickier combinations problem, because we actually have to multiply different combination totals, and then also kind of a probability question, and understanding that really every time we do a probability, we split it into 2 parts, a favorable part and a total part, and then write the fraction for those.